Okay, students, welcome to the afternoon session of your ESCS 291 lab. Okay, so this is about the C programming lab, and today we are actually going to implement some practice of some functions. Okay, in C language, right? So before we start, let me just requesting you to join in the stream and write down your section and roll number immediately. Okay, as we are basically tracking your presence in the live stream, so you have to submit your roll number and the section. All right. So we just going to start in a while. Okay, so I think now it's okay, and we can start the session with the fundamental idea about the function. Asha, one thing I want to tell you that I have already give you some exercise after doing this session, that is your lecture session, or as well as the doubt clearing session. You have to do those in your machine, laptop, or maybe in the smartphone, and whatever output you are getting, you have to submit it along with the report. Okay, so that you have to submit. Okay, and parallelly I am already sharing the IEM test code in your Google Classroom, so you have to appear for the test, and as you are appearing for the test, your attendance will also get recorded. Okay, so that is our thing that we should follow. Okay, so now we have to start with the concept of function in the C language. Okay, now function is a very elementary concept for any programming language. Maybe you are using C, or maybe you are using Python, you are using Java, any kind of programming language that you use. Generally we have the concept of function. Now function is a thing, mathematically you can say that function is basically used for performing certain job and operations. Okay, so in C language also, or any other programming language also, function is mainly used to perform certain jobs. Okay, majorly when we use the programming languages like C, or maybe Python, or maybe Java, there are lots of modules are there in a general situation or in a standard situation. Okay, although in our case, when we write the program for in our laboratory experiment, all these are having very little number of codes and all this, but in general practice, if you go to the industry, or if you do a research on different things, then definitely you have to write a lots of code, and there are lot of line of codes are there. So in order to just modularize, or you can say that in order to create some separate module, or separate feature for the different and aspect of your code, you can actually use the functions. Okay, so the function, the basic idea or the basic concept behind the function is there are several different purposes are actually involved with it. First purpose is that the program, whatever you are writing, you can actually make modules of that by using the functions. Okay, secondly, as your program get moduled, or you can create the modules, different modules depending upon your usability, you can use that set of module for different purpose, or maybe one module can be used or reused in many times. Okay, so that is one of the important feature of the function is there. Okay, another many major important thing is that as your program will get modularized, it means that your program is segmentized. Okay, and as it is segmentized, so you can say that a particular piece of code, which is maybe have huge amount of lines, get splitted into several different functions, so your program readability will also increase. Okay, so imagine suppose you have a 1000 line of code in a single source file, you have a 1000 line of code. So finding out the error within that 1000 line of code is pretty hectic sometimes. Okay, So what is the alternative way? You just split that particular 1000 line of code in such a way that a particular logic or particular operation will be in a separate module, another separate logic or another logic is in another separate module, and so on. So in this way you can actually split your entire logic into several different functions, and whenever your error is occur, literally you can go to that particular logic or that particular module, and then you can find out that what is the error is there. That means chances of understanding the errors, chances of if just review your error is pretty much easier as you are making modules of your functions by using the functions. Okay, so specifically you can say that in general practice, what we do, we can write the functions in different same file if your number of code is very much short. But in real life situation, what we do, we can write the functions in different files also, and then you use that file in my source file so that it can be physically achieve the modularity. Okay, so that is one of the important aspect of function that you should understand, that why should I use the function. So main objective is that module, that means making the module, making some independent modules which can be used or may be reused for different purposes. Okay, so that is one of the feature that you need to mainly focused on, right? So and we expect that when you design any program, and at that time maybe a project also, you have to follow this rule. That means create your logic in a single function and then use that function according to your choice. Okay, so that is the one of the important thing that you should think about. All right, so we can consider the function something like this. If we see a major function, what we generally use is basically known as the main function in our C program, that we already know. As well as with the main function, we can also use certain other function which are known as the user defined functions, all right. So first of all, we have to deal with the different user defined function and how they can actually use. So a very basic syntax of a function is something like this. Say void fn, then some int a comma int b. Okay, and then it is the function block starts and here the function block ends. Okay, so this particular syntax is basically the fundamental building block of the function. Okay, so what is that? Void is basically known as the return type of the function, fn is the name of the function, and int a comma int b, these two particular things or these two particular variable declaration here known as the function parameter. Okay, so just write down void is the return type of the function, int that fn is basically the name of the function, and this int a, int b, or maybe any other thing that you incorporate within the parenthesis is basically known as the parameter, or sometimes known as the formal parameter for the functions. Okay, so basically what the function will do, function will take some data from other sources or other functions maybe, and then process that particular data within it, and then it can maybe return or maybe it can directly display it. Okay, so that's why we are actually declaring this particular body. Okay, so this particular within the curly brace, whatever you are writing is basically known as the function body. Okay, so what we can do, we may declare something like this here, say int c, then you are writing maybe c equal to a plus b. Okay, and after that you are writing printf percent d comma c. Okay, so this is a very standard form of that function, that what is actually it is doing, it is taking A and B from the outside world and then create a variable declaration, and finally it will perform C equal to A plus B, that is addition of those two values, storing into the C, and finally printing the value of C. That means you see that A and B, these two variables, or whatever you can say, the data is actually coming out from the outside world. Okay, so it is the job of the function to connect with outside world and take the data from here and then process it into it, and maybe it may return the value sometime, or maybe it can directly display the value. Okay, so this is the main objective of the function. Okay, so what is happening now, if we want to use this function, so what should I do? Basically, in order to use this particular function, I have to call this function from any other function. Okay, so hopefully the fundamental idea that from where to call this function, we have to, in general, we have to use the main function as a calling function. Okay, so that we call that function from the main and then execute the function as well. Okay, so suppose before that I am writing int main. Alright, so just writing int main and main body starts. Now here I am writing fn 5, 6. Okay, then you can write return 0. So suppose if I do this int main, then fn 5, 6, after that return 0, then bracket it ending, and after that here the function starts. Okay, so in this scenario I can say that this void fn function is actually called by the main function. Void fn function is actually called by the main function. So that's why I can say that int main, this function, is basically the calling function for fn function. Okay, it is known as the calling function for the main function here. Okay, and fn function, this void fn function, is basically the called function from the main. Void fn function is the called function from main function, right? So this is the concept behind calling function and called function. When to use call, when you can say this is a calling function, when you can say this is a called function. Okay, that's a pretty much important thing. All right, so when you are calling a function fn, suppose here we are passing 5 and 6, two values, so that our objective is what? Our objective is to create, or our objective is to add these two values, right? So this is the values that we are actually coming, or you are sending through the function. Okay, so what happens basically when main function invokes this fn function, at that time definitely the function will start executing. That means as the function start executing, the control will immediately go from fn function to the, from the calling point to the body of the function. Okay, so it will immediately jump over there. Suppose I am writing, say, a printf here. All right, say %d, or maybe just hello. Suppose I am writing this here. So what will be the execution sequence here? First of all, the fn is invoked. Now as fn is invoked, that means the program will actually hold at this point, right? So no further execute, that means printf will never execute at that point. Okay, so first what it will do, it will control, it will immediately jump into the fn function, that is the body of this fn function, or sometimes known as the function definition. Okay, so here is the function definition. So you have to just execute, or your system just start execution of the body of the function. So what happened, this 5 will immediately copy to the variable a, 6 will immediately copy to the variable b, right? And after that the body will be get executed, that means c has been declared, and then c equal to a plus b will be happen, and after that the value of the see get printed here, and as it is printed and the task is completed, now it is immediately the function control will immediately jump into this point, that is a calling point. Okay, and after jumping into the calling point, now the normal course of execution of the main function will be happen. That means it will be do this, after that that will print the hello, and then the program will terminate. Okay, so this is the execution step that is actually going on while the function is executing. Okay, so basically from fn to it immediately jumps into the body, then the body will entirely executed, then control will return to the calling point again, and from the calling point it will again the normal course of execution will be persist. Okay, so that is the thing that is actually happen whenever you declare or when you are defining any function, right? Abhishek Pal, you are telling that will you give the function exactly? We have to discuss about the function prototype just later on, just after this example when we try to execute it. Okay, so function prototype is a pretty important thing that we need to execute. Okay, so now let us give an example that how actually you can run the function in a standard compiler, might be DevC compiler. Okay, so just consider this program first. Okay, so here you can see here is the same program, that whatever I have just discussed over here is the same. Okay, so but there are certain differences there. Okay, so what are those difference? You can you have to understand that is what. First of all, we are using stdio.h, it is okay. After that, here another line has been written. Now can anybody tell me what is this basically? This particular declaration or the statement is known as the function prototype. This is known as function prototype. Now why it is needed? Basically the function prototype is not a mandatory thing, it's optional, but in the case where you are running the main or where you are executing the main function before all other function, in that scenario you have to mention the prototype format of your function. Now this particular prototype is basically known as kind of a abstraction of the function. That means you are mentioning the name of the function and the parameter type that are moving from the calling to called function. Okay, so you can see here is the name of the function, and here are the parameter types of the function, and here is the return type of the function. So you have to mention explicitly before the main function that this type of function we are going to use further. Okay, so if you write prototype at this point, that means that you can write the main function first, and after that you can write that function body or the definition of the fn function. Okay, so this is the hard and fast rule for those function which has been written after the main function. Okay, now the interesting thing is that if you write the main function after this void fn function, at that point prototype is not required. Okay, at that point prototype is not required, right? But it is a standard practice, standard programming practice, that sometime we should maintain that we are writing the body of the function later, so therefore we have to use the function prototype like this. Okay, but the prototype, the standard thumb rule of the prototype is that you have to mention the return type, the function name, and the number of parameters and type of parameters. All right, and it is followed by a semicolon so that it will be terminated. Okay, so this is the thing that we are going to see. Now just come into the main function. Again you can see main function a equal to 5, b equal to 6 I am mentioning, then I am calling fn a comma b. Okay, now here fn a comma b, now you can easily understand that this fn a comma b, that is nothing but this void fn int x comma y. Okay, now here two things are very important. One thing is these particular parameters. Okay, now over in the previous example that we are writing, we are directly writing 5 and 6, but here what we are doing, we are writing the variable names, right? Now this parameters here which are actually you are giving is actually known as the actual parameter of the function. It is known as the actual parameter of the function. Now whenever you calling the function, mind it, whenever you are calling the function, these particular values or the variable values are simply get copied into the value x and y. Okay, so you can consider that a and b are two variables, x and y are another two variables. Alright, a and b are two variables and x and y are also two other variables. Okay, so we can see these variables are basically known as the actual parameter variables. These are the actual values, so these are the actual parameter variables. But whatever these values, these value or these variables are actually known as the formal parameter variables. These are known as formal parameter variables. Now why it is formal parameter? Because this actually contains the actual values, whereas this contains not the actual value but the copy of the value, it is holding the copy of the value instead of holding the actual value, right? So that's why these are known as a formal parameter. And after that, what we are doing, perhaps you can understand that we are just incrementing the value of x and incrementing the value of y, and then try to print the value of x and y. Okay, so what it will happening that we are copying the value of a to x and copy the value of b to y. Okay, and as they are copying, that means original value will be remain intact, but the copier value are get actually coming. And then perhaps when you are incrementing the x and y, that means the copy of the value get incremented and they will get displayed over here. Okay, so this particular operation of parameter passing mechanism is a pretty important mechanism which is known as the parameter pass by value mechanism. 80% of the time you may use pass by value mechanism in order to produce your output, but sometime in some crucial cases we may use another technique that is known as pass by reference technique. Okay, so let us first of all execute this particular code. So compile it and then try to execute it. So you can see new values 6 and 7, old values 5 and 6. Okay, so what are the old values? These are the old values a and b, which are basically the actual values. But whenever you are passing those values through the function, you can easily say that this value will get incremented. That means the new values of the parameter are actually incremented. Okay, and this actually holds, and this actually happens due to this operation that is known as the pass by value. So we can say that in case of pass by value, original values are not changed, it is remain intact, but the copy of the value will change. That means what? You are actually making Xerox of these particular variables and you are making the operation on the Xerox copy of the values, not in the actual values. Okay, so that's why it is the pass by value technique, and this is in this case definitely original value will never remain changed. It will never remain changed. Okay, until it will be always remain intact. Okay, so this is one of the major thing you should understand when you are writing the functions, right? So I have covered the pass by value technique as well as the function prototype, that when we should use the function prototype and when we should use the pass by value, and what the pass by value basically is. Okay, now come into another important aspect of the function passing, that is the pass by reference. Okay, So in case of pass by value, what we are doing, what we have done, I'm just giving a diagrammatic approach so that you can easily understand that what we have done actually in case of pass by value. Suppose there are two variables are there like this. Oh, sorry. Suppose this and this. Okay. Say this is your A and this is your B. Say this is 5 and this is your 6. Okay. And this is the variable name is A and this the variable name is B. Okay. So when you are making pass by value, what happen? You are actually copying the values. So suppose this is my X and this is my Y, and what you are doing, you are actually making copy of this particular value 5 and this particular value 6. Okay, and then you are performing the increment plus plus or minus minus whatever. So you are doing this plus plus, x plus plus and y plus plus, the result will become 6 and 7. Alright, so this is the case that in the previous example. Okay, now if we want to make the pass by reference, then what will be happen? Just look at very carefully. In case of pass by reference, basically we are not passing the values. Okay, perhaps we are actually passing the address of those values. So I can say that if I have A and B, these two particular variables, then definitely they also have the addresses. Suppose the address of this is say 2000. Okay, and say address of this is say 3000. Okay, so say address of A is 2000 and address of B is 3000. So in the pass by reference, we most of the case use the pointer variable in the formal parameters. So maybe it is like that, star x and star y. Okay, so star x and star y may be two pointer variable where we are not storing the values, but we are actually storing what? The addresses. So maybe 2000 and 3000. So what we are doing, we are just storing the address 2000 and 3000 in the pointer variables, and then what we are doing, we are actually performing the value at address operation. Maybe some in majority of the case like this, set star x plus plus and star of y plus plus. So if we do this, instead of doing your, or if instead of copying your values, what will be the ultimate result? The ultimate result will become something like that, that we are actually acting, or you are actually updating the actual or the original values. Okay, not the copy of the values. In case of fall by value, we have to have the copy of the values. Now in case of pass by reference or call by reference, we have to use original value. That means whatever changes we have made, it is actually made over the actual values rather than the formal values. That is the major difference between pass by reference and the pass by value. So in the previous example that we have discussed is basically the pass by values. Okay, whereas this example is a pass by reference where we have to use the pointers. Okay, we have to use the pointers. Acha, Suil Haider, you are telling, sir, we have test now on IEM CRP. Yeah, you can avail the test. Okay, but there are I think up to 4:15 you can give the test. Okay, so don't worry about that. This is a very short test. So after completion of this class, you can do the test. Maybe I can take at least 15 minutes of time. So from 3:30 onwards, you can take the test, right? So no problem about that. So is it clear to everyone that what is pass by reference and pass by value? Make sure that you understand pass by reference and pass by value, because this is a very crucial approach that it should deal with, right? So now go for the second example, that is this pass by reference operation. Now in the pass by reference, same thing, only the difference is that in the function prototype you can see we are using insta. That means there are two pointer variable we are going to use, right? Same program, just we are updating it, right? Values are same. Now in the calling function, what I should write? In the calling function, we should write, instead of writing A and B, you just write ampersand of A, ampersand of B. Why? Because your ampersand of A and ampersand of B is basically a kind of the address of operator through which the address of A and B will get passed, right? So after doing this, what it will going to happen? It will immediately pass into the body of the function. So here ampersand X will store into this, ampersand A will store into this star X, ampersand B will store into star Y. And perhaps what we are doing, we are performing start of X plus plus and start of Y plus plus. So what do you mean by start of X? Start of X is what? It is the value at address location. That means it will fetch the address and then it will redirect to the redirected to the value, and the operation has been done over that value. Okay, so you can easily understand that it will simply redirected to the original copy of the value. Okay, it will simply redirect to the original copy of the value, and hence it will increase the variable value as well. Okay, so star X will directly affect to that value A. Okay, and it will immediately incremented to 6. Star Y plus plus will directly affect on B, and it will immediately increment the value of B to 7, right? So we can see you just see that there are two printf statements are there. All right, there are two printf statements are there, right? So definitely for this particular statement, what will be the result? Can you tell me? It will be simply 6 and 7, and after completion of this particular operation, the program will again come into this line, and after that it will again execute another printf statement, right? So that is printf %d a comma b. So what will be the ultimate result? The result is same. That means whatever value 6, 7 in updated within this particular call function, the change will immediately reflected to the calling function itself. Okay, to the calling function itself, right? So just try to execute it. You see, formal value 6, 7, actual value is 6, 7. So what is the formal value? Formal value is actually accepted, or formal value is actually manipulated at the body of the call function, right? So it is 6 and 7, and also your actual value is this one, so it will also 6 and 7. So this is the main difference between the call by value and call by reference. That call by value means it is basically changes will be done into the body of the function, or you can say and the copy of the value of the function. Okay, and in case of call by reference, the changes has been performed at the original copy of the values. Okay, so that is the main difference between call by value and the call by reference, right? So I think up to this it is clear. So you have any questions? Achha, Obisek, you are telling please explain with please explain with strings. Strings means, see, if you consider string, if you can consider them as a character pointer, something like this. Suppose you have say char star ch equal to say hello, alright, and then you are just trying to pass this as well, char star maybe, and doing this say ch. So here you can write like this, ch char star c. Then you may change the values here also, maybe what I can say, you can increment the value or anything else, or maybe you can concatenate with any other string, and then you can print the value as well, like this, %s comma c. So it should give you the result, as well as the thing will be there. So what is that? Cat star warning is there. Okay, no problem. So here 6 7, and then hello is actually get printed, right? So you can directly pass your any character, any string as a pass by reference by using as a character pointer, right? And if you make any manipulation in the as a formal value in the body of your function, then that could be also acceptable. You can even change, you can even concatenate with any other strings or anything else, and you can perform any kind of string manipulation as well if you want to do that. Okay, so for a particular string, I can say it is expected or it is recommended to use the pass by reference techniques, because a string actually stores into as a character array or maybe as a character pointer also. Okay, so you can do that. So this is one of the example. Then a third example that I am just going to show you, that is a function that is actually returning some values, right? So returning some values means it is actually the return type that is actually involved with this kind of scenario. So consider this particular example, that is int fact int. Now this is a typical example of just computing the factorial values. Okay, so we say you are telling no need of ampersand for arrays. See, if it is a string, then definitely you should not use ampersand, because if it is an array or kind of a pointer, then definitely the name will be sufficient, because name holds the base address. Alright, so you should not use that. Okay, so now come into the second one, that is third one, sorry, that is your how you can return some values. Okay, now one thing you have to understand, that your in case of C language, basically function returns at a time a single value, right? So you cannot return multiple number of value through the function. In Python you can do that. Python you can return multiple number of values, but in C there is an alternate approach is there, that is if you return the reference, or maybe if you return the pointer address of any array, then you can consider that it is a multiple number of values that actually get returned, since you are returning the multiple number of the base address of any array, right? So in this way, in an alternative way, you can return multiple values, but directly if you return, suppose you want to return, say return 2, 3, 4, or return a, b, c, it is not possible for C to handle. Okay, so in C always it will return a single value. It will always return a single value, mind it. Okay, so now come into this particular program. So what is the main thing about this program is just to ensure or just to view that the nature of calling. So how you do actually call this particular function? Fact function, you are writing res equal to fact v. Okay, so this is one of the way, or maybe you can write like this. Say printf, you are writing %d comma fact v. Okay, so you can write in this way also. Okay, so that whenever your function returns some value, it will immediately get printed by printf function. Okay, so this is an alternative way. Now for the sake of simplicity, I am just writing over here that res equal to fact v, and then you are printing the value of factorial here, right? So what is that? That is as you are calling the fact function with some value, it will immediately come over here, right? And as it is coming over here, after that you can see that you are making some statements right here. Now these statements are very simple statement. It is about the factorial computation of factorial that you are already, I think all of you know that if I want to compute factorial, then first of all I have to check that whether the value of n is 0 or not. If it is 0, then you have to return 1, and also if you have n equal to 1, then also you have to return 1, right? Otherwise you just take a loop and starting from n to 1 and compute the value t equal to t multiplied by I. Okay, so t is basically a temporary variable where your temporary result gets stored, right, with the iteration of your loop from n to 1. Okay, so you can do this, or mainly you can use greater than equal to as well. so that it will actually ensure that you are computing from n to 1. Okay, so that's why you have to write greater than equal to. Okay, and after that you just return the values. Okay, so here what you are doing, returning t. So when you are returning some value, where it should return the value? Okay, so you should know that where we should return that particular value. So our returning of that value should be at the point of calling. That means whenever you are calling that function, the function will immediately start execution from this line. Okay, then this if condition is satisfied, and then fine, or not, then else condition satisfied, it will compute it, then it will immediately go to the reach to the return statements. Okay, so now what you need to do, you need to return that particular t value at this point. Okay, that means the calling point of the function. Okay, and it will immediately store into the left hand side value. And finally you can do, you can print that particular value as well. Okay, so this is the nature, or this is the way through which you can actually return a value into the function. Okay, into the calling function, right? So it is pretty much useful that whenever you are using a function that must return a value, and that particular data can be useful. Okay, so this is one of the examples that you have to do in your lab also, that how you can compute NCR and all that. Okay, by using the factorial concept. Okay, so try to do this program as well. So now I can say that if you have any questions about any kind of thing about the function, then let me confirm, or let me just know that whether you have any questions or not. If it is okay, fine, then you just go for the next part, that is just start doing your laboratory session, and also of course you have to appear for the IEM CRP test. Okay, so is it okay? Anyone? If you have any question? But mind it, this part of the program, the functions and the usefulness of function, is a pretty much important thing. Okay, You should ensure that you understand all these things from the beginning, otherwise it will be pretty difficult for you, not only in C, but also if you go for Python, if you go for Java, it is there, the function is there. Okay, so you have to ensure, right? Okay, fine. So I think now it's your time to start your laboratory session. So hopefully you follow either the C++ or maybe the GCC compiler and start doing the program and submit it by 5 o'clock. Okay, you have to submit it by 5 o'clock. Okay, thank you very much. Then we will meet you in the next class again. Okay, thank you.